homogeneous linear partial differential equation having constant coefficients. Now question is how to solve it. So like your ordinary differential equation having constant coefficients. So like that we have to solve it. Now before going to this one, you have to take del by del x is capital D, del by del y is d dash, okay, and you have to take symbolically, that is del z by del x is small p, del z by del y is small q, del square z by del x square is r, del square z by del x del y is s, and del square z by del y square is equal to p. So these are the symbols or these are the abbreviations for this. So you have to take like that. So main part is del y del x is you have to take d operator form, and del by del y is d dash. Now you consider this type of differential equation. Del that is del n z by del x to the power n plus k1 del to the power nz by del x to the power n minus of 1 into del y plus k2 del to the power nz by del x to the power n minus 2 into del y square. So this way go on continuing. This is your kn into del n z by del y to the power n, and that is equal to some function of xy. Now this is a homogeneous partial differential equation because this order region, each term, the degree of the order of each term are equal. For that sake, this is homogeneous. And this is linear because the degree of this differential equation is 1. And this is said to be with constant coefficients if k1, k2 up to kn are constants. Now f of xy means f is a function of xy. The right hand side is f is a function of xy. Now thing is how to solve it. Our aim is to solve it. In order to solve it, you first of all take your del, that is nz by del x to the power n plus k1 del nz by del x to the power n minus 1 into del y plus 2 your kn del nz by del y to the power n is equal to 0. And instead of your del by del x you substitute d, and instead of del by del y you substitute d dash. So you obtain this is d to the power n plus k1 d to the power n minus 1 into d dash plus k2 d to the power n minus 2 into d dash whole square plus 2 your kn d dash to the power n operator z is equal to 0. Then you have to take your d to the power n plus k1 d to the power n minus 1 into d dash plus k2 d to the power n minus 2 into d dash whole square plus 2 your kn d dash to the power your n is equal to 0. Then you do one thing, you divide throughout by the highest power of d dash. So you obtain d by d dash to the power n plus k1 d by d dash to the power n minus of 1 plus 2 your kn is equal to. So this is called This equation number 1 is called the auxiliary equation. This is called the auxiliary equation. Okay? Then you will try to solve it. If you solve it, then definitely you will obtain dy d dash are like this: m1, m2 up to mn. Okay? Then you come to your case number 1. Case number 1. Now the roots are distinct. That is, m1 is not equal to m2 is not equal to mn. Then you will obtain the complementary function is f1 y plus m1 x plus your f2 y plus your m2x. So this will go on continuing fn of y plus mnx. So you will obtain the complementary function if the roots are distinct by dint of this formula. You take your case number 2. Now if two roots are equal, say m1 is equal to then you will obtain the complementary function is your f1 y plus m1x plus x into f2 of y plus m1x. So this will go on continuing. Suppose p roots are equal. If m1 is equal to say m2 is equal to m3, then you will obtain the complementary function is like this: f1 y plus m1x plus x into f2 of your y plus m1x plus your x square f3 of y plus your m1x. You will obtain this is the complementary function if the three roots are equal. So in this, in a partial differential equation, there is no question of your complex roots. Okay? Only two cases are there. Now you got the complementary function like this. Then you come to the particular integral. Now you see how to find out the particular integral of this. So you do this first. So differential equation is in this form: f of d dash operand term z is some function of xy. So you will obtain the particular integral is equal to the f of your xy divided by f of d dash. Is not it? Now come to your case number 1. So let us take that case number 1. If f of xy is your e to the power ax plus by, then you will obtain the particular integral like this. And the particular integral is e to the power ax plus by f of d dash. That is equal to, you have to substitute instead of d is a and d dash is b here. So f of ax plus by f of ab provided f of ab is not equal to 0. So if it is 0, then I shall tell you the general formula for this. So come to your case number 2. Now if f of your xy is your sine of ax plus by or cos of ax plus by, the question is how to find out the other that is the particular integral. So the particular integral is your sine of ax plus by by f of d dash. of x plus b by f of dd dash. So you have to substitute instead of d square is minus of a square. D dash square is minus of d square and dd dash is minus of ab. So by substituting this, the denominator should not be equal to 0. If it is 0, then you have to go to the general formula. So there is only two cases are there. Only that is for two cases. So let us take the general formula for this. General formula for finding the particular integral. Now you see what is the general formula here. This is your f of xy divided by f of d dash. You do one thing. You that is factorize your f of d dash. You will factorize it. Then you obtain f of xy by d minus of m1 d dash d minus of m2 into d dash is doing 1 by d. Okay. Then you resolve it by the partial fraction. After that, you resolve it by the partial fraction. So to resolve it by this is your n1 by d minus m1 d dash, n2 by d minus m2 d dash, like that. So one part you take it. 1 by d minus m1 d dash, that is function of x1. How to find out this particular integral in this case? So this you can write, this is the integration of f of x c minus m1x, this is dx. Instead of y, you have to substitute c minus of m1x. If it is plus, then you have to write plus m1x. So this is the key point. So if you substitute instead of y this, then it will convert to only a function of x. So with convert to a function of x, that means this is a function of x with respect to x, you will get it. And the last one you have to substitute instead of c, that is y plus m1x. Then you will get the particular integral. So this is the formula, this is the general formula if f of a b is equal to 0. And by substituting this in the denominator is equal to 0, like that. And this also formula holds good for x to the power n into y to the power n also. Okay. So anyway, so x to the power m plus y to the power n by f of dd dash, there you can't apply the binomial theorem. So you have to take the help of this general formula. This is the general formula. Now you got the complementary function, you got the particular integral. Therefore, the complete solution is z is cm plus what is this?
Yeah.
Okay. Now let us take some problems for Q. Del cube z by del x cube plus del cube z by into del y 4 times of del cube z by del x into del y square is equal to 0. Solve it. In order to solve it, if you look this one, then the right hand side is 0. Only thing you have to find out the complementary function. The next step is you write it in the operator form.
d cube plus d square d dash y.
4d into d dash square operator z equal to
0.
So this can be written as d cube plus d square d dash plus 4 times of d dash square is equal to 0. So this is your, by taking d as common from this, this is your d square
d
plus
d dash plus 4
d dash square
equal to
is equal to
0.
0. Is it? So I have committed some mistakes here. Minus, this part is minus. I have committed some mistake. This 4 times. This is minus 4 times. This is minus 4 times. This is minus of 4 times. Okay? So I can write this is your d into 2 times of d dash whole square is equal to 0. So this implies that d by d dash is one part is 0, d by d dash is 2, another is that it? D is 0 means d by d dash is 0. This is 1 root, this is another root. Now you will look this is coming under, this is the 1 root, this is the equal root. So you will obtain the complementary of y plus m1 x. M1 is what? 0. Oh, y plus this is your f2 y plus 2x plus x f2 of y plus 2x, because these are the equals. So you got this is the complete solution. This. Let us take another example. So you come to your another example for this. Equation. This is your t square minus of 2 d dash plus d dash whole square plus d dash whole square operate on this is z is e to the power x plus y. Now you solve this differential equation. This is d square minus 2 d dash plus d square is equal to
0.
Now this can be written as your d minus of d dash square is equal to 0. So d by d dash is equal to 1 and this is 1 equals, because d minus d dash is 0. So d by d dash is 1, another is 1. So to obtain the complementary function is f1 y plus x plus x times of
f2
x2 of a y plus f2 of
y plus x.
Next is come to the particular integral. So the particular integral is your e to the power x plus y by your, this is d minus d dash whole square. D minus d dash whole square. Now look it. Instead of d you substitute 1 and instead of d dash you substitute 1, then you are getting 0. So the formula x. So I can write this is your 1 by d minus of d dash into the integration of e to the power x plus c minus of x into dx. Because instead of y I have substituted c minus of x. So this becomes your 1 by d minus of d dash into e to the power, what is this? E to the power c, x cancel, e to the power c take constant, you take it outside, this into x. Is not it? Now instead of c, you have to substitute what? Y plus x. So this becomes your, this is your e to the power y plus x into x, is not it? This by d minus d dash. This is nothing but the integration of x into e to the power y means c minus x plus x into dx. X cancelled. So this becomes your e to the power c into x square y. Now you substitute the value of c here, e to the power y plus x into x square y. So this is the particular integral that we got it. Now the complete solution is z is your CF
is
loss
pi.
PI. So here I got the CF, you substitute it. I got this is PI, you substitute it. Then you get the complete solution. So take another problem. Minus 2 times of del square z by del x del y loss del square z by del y square is equal to your sin x. You solve this differential equation. Now I can write this thing as your d square minus 2 dd dash loss dd square
Z
operate on your z
sin x.
is sin x. So d square minus 2 dd dash loss dd square
To
is
0.
equal to
0.
So I can write this is d minus of d dash
The whole
square
equal to 0. So
So this implies
double root
that d by d dash is
equal to
1
1.
and equal roots. So you will obtain the complementary function is f1 y plus x
plus x into
x2 y plus x. Okay. Now I come to the particular integral.
सर आपको x गुणिया बोलते हो सर
Okay.
डबल रूट x
This is your sin x divided by d minus of d dash square.
होल स्क्वायर
No, d minus d dash
होल स्क्वायर
whole square. Instead of d you substitute 1. Instead of d dash you substitute 0. Because x plus y, a is 1, b is 0. So I got this is
sin x by
your sin x by 1 square is 1. So you got sin x. So the complete solution is z is CF loss PI. Write the CF. PI that you got a sin x or z is this.